welcome back to Tech Tips, Fixes and More. My name is Ron, and I'd like to wish all of my viewers a very Merry Christmas. We're coming up on Christmas time of 2024. I would also like to remind you that the Christmas season is about Christ and His coming to earth. So it's always good to focus our attention in that direction, because that is the true meaning of it. So let's get to the video. Today I'm going to be working on a little project rather than on a fix. Now, I've enjoyed over the last few years playing around with some of the Arduino and Raspberry Pi stuff. I'm not extremely knowledgeable about this stuff, but it is a lot of fun to play around with it. It's inexpensive, and there's just a ton of information online. Lots of places where you can get ideas, where you can learn stuff, where you can get programs and projects. So this video, in a way, may look like I'm coming into the middle of a project, because actually a couple of years ago I got busy and built myself a digital thermostat for my garage that actually works very well, and it's got the features mostly that I want, and it has worked almost flawlessly for the last couple of years. But as time went on, I began to think maybe there would be a couple of refinements that I could add to it, and I would also like to be able to possibly get to the point where I could hook it into a home automation system. So I'm going to review today what I did before, and then we'll talk about some of the refinements I'd like to add to this thermostat, and we'll see if we can get the thing happening and add some features that I haven't had before. So here we are in my garage. Please excuse the mess. This furnace really keeps this garage warm, but it came with a really basic thermostat. Here's the original thermostat, and there's really nothing wrong with it. It's basically just a bimetal strip that closes and opens a contact depending on where you've set it and how much the temperature has changed the flex of the bimetal strip. I really wanted to have a little more features. So here's my thermostat that I built before. You'll see that I've got a 2-line digital display, and on the bottom I've got a temperature and humidity sensor. The power comes in from a 5-volt wall wart over here, and on the display I display temperature, the set point, and the humidity. I don't do anything with the humidity, but it came with the sensor. It's kind of interesting. And then a line that tells you whether the furnace is off or on. So I'm going to increase this, and you'll notice that, do you hear that? The furnace kicked in just there when it hit 11 degrees. And I can continue to increase it up to where I want it. 9 degrees is pretty cool. I haven't been working out here today. I usually put it up to about 18 degrees. There you can hear the actual flames kicking in the furnace up there, and it'll start getting warm in here. So I can increase and decrease the set point using this switch here. I can also switch to a different page. I can go here, and it goes over to the hysteresis page, and so you can see that I've got a 2-degree hysteresis, and the same switch over here will allow me to increase or decrease the hysteresis setting, and I found 2 degrees C is about right. So I can, if I hit this again, I can go back to the main page, and you'll notice that it's heating. And when it reaches the actual set point of 18 degrees, it'll switch off, and it'll show off instead of heating. Now, I can also disable the furnace by hitting the enable button, and you see it comes up and says system disabled. Now the furnace is still running because there's a fan to make sure that it cools down properly, but it actually has disabled the heater. So I want to turn it back on, so I'm going to re-enable it. And there we go, it's heating again. So here's the breadboard setup of the thermostat. This is just a breadboard that I set up after the fact. I didn't take apart the actual thermostat out in the garage, but I wanted to first of all build the thermostat as I have it created, and then I'll be adding some other equipment and functionality to it. So here's the breadboard. What you can see here is the actual Arduino Nano board right here. It's connected by USB over to my computer, where I'm running the Arduino IDE software that allows you to program these things. We'll look more closely at that later. So, but this particular program here is the one that I adapted to use in the thermostat when I originally built it. So I just loaded it up again on this other Nano. And what I've got here is the Nano. Then I've got some push button switches that are there to simulate the switches I have on the thermostat. You'll notice down at the bottom I've put on some green tape here. This momentary push button is the plus button that allows you to increment the set point, and this is the minus button here. This one is an extra one that I'll use a little later on. This is the enable button that allows you to move it from disabled to enabled, and this one here is the page button that allows you to go over to the hysteresis page and reset that. Here's the sensor, the temperature and humidity sensor, and this little board over here is the relay board that actually controls the furnace. The output on this side of that board, the screw terminals, wiring from there goes to the furnace. Then we have a display board here, and you can see it's got the same display as what I showed you out in the garage there. And this particular board communicates from the Nano by the I2C serial interface. So it has a little board on the back that actually allows you to connect by a 2-wire system over to this. You can connect directly to this display, but it takes several conductors, and that uses up I/O on the actual Nano. So here's a schematic that I drew up of the system, and just to give you a little bit more detail. So I'm showing the front side of the display and the back side of the display. It's a 1602 display with the I2C adapter on the back of it, as I mentioned before. And then I've got my 2 switches that are used in the actual thermostat. Here's the Nano, here's the relay board, and here is the temperature and humidity module. And I just showed the connections. Over here we have just some terminals, because I needed a spot to connect ground and VCC, which is 5 volts, to several places in the circuit. So I put in a little terminal block so that I could just solder multiple wires to it and distribute power throughout the system. So that's my little schematic. So what I hope to do, my first step will be to add this little board here. This board's a real-time clock, and It's very inexpensive. It's got a little battery on the back for maintaining the time. And so you can actually then hook this up using that same I2C interface, and then you can set up times when you want the thermostat to turn on and off. My idea there was that I'd like to have the system automatically turn itself down at the end of the day, just in case I forget to turn the thermostat down. I don't want the furnace running all night in the garage and using up energy. And there's other things you can do with it, turn it back on in the morning, and a bunch of other things. So that's one of my goals for that. Also, with this extra switch here, I'd like to put in a functionality where I can, when I walk out into the garage, I can just push that button and it'll automatically turn the thermostat up to a preset temperature. And then I can, I don't have to ramp it up and then ramp it back down later. And that same input, I think, could be used with the real-time clock, so that it'll turn it up at a certain time in the morning and turn it down. My next step after that will be probably to add another controller, probably an ESP32, which has Wi-Fi capabilities, which would allow me to connect it into a home automation system. Okay, so let's take a quick look at the thermostat sketch for the Arduino. Just a quick disclaimer, I'm no expert as a programmer, but that's one of the beauties of working with Arduino. There's an awful lot of software that's pre-written for it, and there's a lot of stuff online. So what I've done is I just went out and found some good sketches that do basically what I wanted, and then I made some changes to it, and as I understand it, that's done that way all the time. I'm always happy to get comments on this, but I'm not going to claim to be an expert. So looking at this first part, I've just commented out some notes basically to myself so that I could remember later what I had done here. So in this commented out section, it says that there are 3 screens: the system disabled, the main control, and the hysteresis screens. The system disabled one, what happens there is there's a variable called enable state, which when it's 0, the system is disabled and the relay is de-energized. So then in that situation, the furnace is not on and can't turn on. And when you press the enable button, it'll toggle the enable state to a 1. And when that happens, menu number 1 appears, which menu number 1 is basically the main control menu here. And in the main control menu, it shows the temperature, T, it shows the set point, S, and it also shows the humidity, which of course we're not using for anything other than just to display it. It also, in the second line, shows whether heating is, whether the furnace is heating or whether it's off. And in that case, when the variable called relay is a 0, it's de-energized. And when and in that case the heater is off, and when the relay variable is set to 1, the furnace is on and it's heating. Now, one little point about that is that I wanted to try and make this somewhat fail-safe. So if the relay were to fail, which typically would fail in the open or non-energized condition, that should turn off the furnace, because we don't want the furnace to run continuously if the thermostat fails. Now, there's always a possibility that an electronic component could fail in the wrong state, or something further back in the electronics could fail in a state that keeps it de-energized. So it's not a perfect fail-safe, but it does help somewhat in making the system more fail-safe. So then the next screen is called hysteresis, and or it's also called menu 2, and it basically just shows the hysteresis value, and that's typically 2 degrees C, but it is adjustable, and so you can change that by pressing the toggle switch towards the plus or the minus, and it increments or decrements that particular value. Let's say we set the set point to 20 degrees Celsius. When the temperature drops to 18 degrees Celsius, it will turn on the heating, and it will heat up until the temperature is equal to the set point, and then it'll turn off. That way, if there's a little bit of hysteresis in the system, it doesn't turn on and off on a constant basis every few seconds. It has to actually cool off for a few minutes before it can actually kick back in. You don't want too wide a hysteresis, or your temperature is going to vary up and down a lot. Also, you must return to menu 1 before pressing the enable button to disable the system. Okay, so that's the part that I've commented out. In this next section here, basically we set up the libraries, and again, this is one of the beauties of Arduino systems, is that a lot of the code that's written has been pre-written for you, and standard functionality of these various modules is within these libraries, and you just load them up and then they operate the way the thing is supposed to operate. So in order to bring in these libraries, you use the include command, and you include the name of the library. In this case, the wire library is for I2C communications, which is a serial communications protocol that allows the Arduino to talk to the serial board on the display unit. And I should mention that when we add the real-time clock, we'll have to include a library for the real-time clock so that it can talk to the Arduino via the library as well. Next one is include the liquid crystal library. I guess the way to describe this is that the wire library is the one that sets up communication for I2C, but the liquid crystal I2C library is specifically how the LCD can be communicated with using I2C. And then the next one is include the DHT libraries from Adafruit. Now, the DHT is the humidity and temperature sensor, and so there's a library that allows you to talk to it properly. So we load that library. And then there's another comment here that says wiring. The SDA pin is connected to A4 and the SCL pin to A5. So that's just a little hardware comment just to remind me what pins for the I2C communications went to where on the Arduino. Then we connect to the LCD via the IS2 board that's on there. And those boards all have an address on them, and this is in hex and hexadecimal. And the default address for the LCD is 0x27, and which means that you don't do any jumpers on the board. If you want to change that address, you can do it. When we hook up the real-time clock, we will have to use a different address for the real-time clock, and as I understand it right now, it typically uses a different address, so I'm probably not going to have to make any changes to it as well. So in this next section, we're going to set up the temperature and humidity sensor. Now, the original temperature and humidity sensor was a DHT-11, and that's the inexpensive sensor that comes with a lot of these Arduino kits. And it works okay, but it's just not all that accurate, and I wanted a little more accuracy in this. And so I found out that you can get a DHT-22. It's a little more expensive, and I ordered one of those up and put it in. So you have to actually define which sensor you are using for the library to work correctly. And so you put that in here, define it, and you also are defining the pin that you're going to use on the Arduino. Then the next section just sets up the input and output pins on the Arduino. The name of the variable associated with the pin is given, and there's additional information as to what kind of variable will be associated with that pin. So we specify that there's a relay pin, there's an up-down pin, those connect to the switches, there's a menu button pin and test LED and enable button. The test LED was something I had in there at the beginning so that I could test this without necessarily using the relay. Then there's another section here where we set up variables that are not associated with pins on the Arduino, and we have up button state, down button state, hysteresis, and so on. Then we set up some other variables. These previous variables are integers, so whole numbers, whereas these ones are floating point variables. And so we have a variable for the humidity, one for temperature, one for the set point, and one for the differential. And then in the next section here, we just set up the temperature sensor so that it operates correctly with this Arduino. Void setup signals that this is the beginning of the setup section, and we initialize the inputs and outputs so that there's a known starting point for them, or known starting status of them. And then we initiate the LCD so it starts to work. Then we initialize the temperature sensor in a similar way. And then we initialize the floating variable values. And at that point, then we're ready to actually start the loop. And of course, this program operates in a loop. It repeats over and over again, so it can keep updating the status of the temperature and check the buttons. So we've got a little section that checks the enable button, and if there is a toggling of the enable, it tells it what to do. This section basically looks at the switch and decides what to do with the input from it. There's a delay in here so that the temperature sensor can stabilize. And then this little step here actually goes out and gets the humidity and temperature values from the DHT22. Next, we clear the display, and we basically set up where we want the information to be printed. Now, the way this relay works, you have to have a relay state of 0 to energize the relay, and the relay is energized to turn on the furnace. So a relay state of 1 then indicates that we have turned off the furnace, which is what you would want if the system is disabled. Then we've got another if-then section here, which talks about if the enable state that has been read is a 1. And there's another delay, and so on. And we do similar kind of a process in here in order to, first of all, read the state of the push button switches, update the set point, and increment or decrement the set point. Then we set the relay output to 0 when the temperature drops below the set point, less the hysteresis. And this is what I was talking about before, where we want, when the actual temperature that's measured is the set point value less typically 2 degrees, then we set the relay output to a 0, which energizes that relay, which then turns on the furnace. And then we change what we're displaying on the digital display, and so this again sets up what's seen on the display and lays it out, formats it there. Then there's another section here that looks at menu 2, the hysteresis menu, and it's somewhat similar. Again, it's about displaying what we get, and reading the state of the push button switches and updating the values so that we can display the correct amount. So that's a very broad and quick explanation, but it basically lays out the overall map without going into much detail. Okay, so I'm going to wrap this video up. In this one, we basically have just looked at what I built in the original version 1, let's say, of the garage thermostat, and showed you where it is and how it works a little bit, and giving you a little bit of the insight into the sketch and how the programming was done. So in the next video, we'll add in the real-time clock and some other features, and we'll put that into the breadboard, do some testing, debugging, make sure that everything works, and then we'll either build an add-on to the existing thermostat, or we'll do a rebuild of the whole thermostat and reinstall it and test it in situ. And we'll look forward to getting that out to you as soon as we can. So I invite you to like and subscribe. I'm actually trying to get the channel numbers up a little bit as we go into 25, so I'd appreciate if you would subscribe, and if you would like to leave any comments or questions, I'm always happy to take a look at those and see if I can help in any way. Again, Merry Christmas, all the best in 2025, and we'll see you on the next one.